And my role here is a kind of, I think, interesting from the position to present to you a kind of linkage between laboratory medicine and between the mostly clinical biobanking, and somehow to put this and to somehow to present this or to melt it in the form for future patient benefit. As was alluded to by Jiří Vondráček, BBMRI-ERIC is one of the medical research infrastructures which essentially, I want to say govern, this word is not very much appropriate, but plays a major role in a current landscape of clinical research in Europe. This is important to realize that within the last 20-30 years there was a substantial change in the legal landscape in mostly the last 2 decades. Simply saying that all the discoveries which are made here cannot be applied in a patient-centric manner unless properly translated through a set of clinical trial system or the system which somehow allows you to apply this knowledge to the ultimate end user. As we were talking the whole afternoon about the patient-centric approach, this is simply one of the examples, which we are talking about today. And we see here the circle within the public healthcare, and somewhere over here, this is our world. This is the world of clinical laboratories, where we work, where our expertise is, and this is what I mentioned a little bit more, because, the biorepositories, the actual biorepositories are closely linked to this kind of mostly academic hospital departments, as we saw, as we were discussing this afternoon. So among other research infrastructures, which are nowadays being ERICs, meaning the European legal person, and have something to do with the medical research, it is BBMRI-ERIC, ECRIN-ERIC, which is the infrastructure for academic clinical trials, and this is EATRIS for the translational research. And as Jiří was presenting here a while ago, it is of course Elixir with the huge informatics support, which is provided to this system. Now, personalized medicine, as we perceive it today, brought us a couple of challenges, and I really don't have time, to go into details. But one of the elements, one of the paradigms we had to change was that we have to somehow switch back from population means back to case selections, because we are speaking about persons, about personalization, etc., etc. And this is a key. These are the keys to the focused studies. Focused discovery omics studies require then carefully selected cases. And the very extreme to this approach is one of the techniques which are used in clinical trials today, and these are called single patients or the N-of-1 trials. So that this methodology is already somewhere over here. And these cases have to be uniform in as much parameters as possible, except one key feature, for example, long-term survivors, non-responders to a given therapies, etc., etc. So to make it happen, we have to have these cases. So the cases must be available. That means that the linkage of biobank samples to complete medical history is a clear must. And what is important to realize is that the entity is not a specimen vial, but it's a sample data set. It's actually the aggregate information on the patients, on all the corresponding information, etc., etc. So that, this is, again, the change of the paradigm on what is essentially the biobankable entity. And the last, the data sample sets must be carefully selected and cleaned up by a medically qualified specialist. And I will show you in a couple of slides how it looks on a daily basis in our pathology departments, because, the clinical specimens, as I was alluding to, requires laboratory medicine and pathology diagnostic infrastructure. Unless having it, we don't have any kind of meaningful biobanking services. And why is that? It's because the tissue material is essentially a surgical leftover and must be taken before the diagnosis from non-fixed resection specimens. and the sampling must not hamper the process of diagnosis. And the qualified board-certified pathologist must perform a set of operations, which I show you here. There's the surgical resection specimen with this particular stricture. Behind that stricture there is a tumor, so that you know what the pathologist do as a next step is that he or she opens, you know, the large bowel. Here you can see the surgical clips. This is the area of the tumor. This is actually the swab where actually the pathologist is taken the specimen for the microbiome studies. Yeah, so that's the difference between infrastructure and the project. Yeah, that's actually a nice demonstration. And then you end up, if you are lucky enough, you end up with such a tiny piece of tissue, which is the surgical leftover, where pathologists can say, well, this one can really go to our biorepository without compromising the diagnostic procedure. Yeah. So summing up, the natural course of the disease, such as cancer, actually somehow dictates the way how at some institution, and what I'm showing you here is the way how we have been doing this at our institution. This is time, so these are the patient entries around the time scale. So here you can see the operation time. So this is one point where we can take, you know, the respective tissue specimens. Then the patient comes again for the treatment. Any kind of liquid specimen, traditionally it is serum, but as we learned, and as was discussed also today, a couple other specimens can be collected during this time. And then for the rare cases of reoperation, we can get for one set, one unit, one patient, you know, one biobanking element, we can get, you know, this set of biobankable biological material. Now, what's the role of BBMRI-ERIC in this system? If you just recall what I presented like 2-3 slides before, the cases must be available unless there is nothing up here. Yeah? So this is actually the way how to organize it in a way that the system works. BBMRI-ERIC right now comprises 20 member states plus IARC in France, and it's essentially the federation of biobanks and other resources across member states. And again, as was mentioned here by Izzy, one of the reasons is to make the data more fair, yeah, findable, accessible, etc., etc. And the ultimate aim here is of this community, and which is mostly the medical research community, is to improve efficiency and reproducibility of the medical research. This is essentially a kind of different view on the same thing, how you link essentially the patients through the various hospital services, biorepositories, researchers at this part, and then what is essentially researched, so to speak. Here how it should be returned through a kind of clinical trial process back to the patients. So, as I said, this is a federated hierarchical infrastructure, but what is important, I will just, mention, in my view, what is the most important things to remember from my talk is that the biobank is really not the specimen per se, it's the combination of expertise at the first place, samples plus data, and services, yeah? And why is that? That's the painful issue of the research reproducibility, which somehow started, in 2012 by publication, well-known publication in The Economist, simply saying that the percentage of irreproducible research is really, really high. So one of the ambitions of BBMRI-ERIC is to do something to make the situation improved. One of the things which appeared were additional fair health principles, somehow adding united view of biological material and data. I explained this already, and reproducibility and reusability. So that means a kind of double R for this particular situation. It also will not work without sound incentive scheme for those who are involved in this process. So just putting this in a plain language, we need to give all the participants, in the hospital laboratories the reason to do it. And the privacy protection is something which is quite obvious under GDPR today. So this is essentially from a published source. When you take roughly one portion of reproducible research, the other one is the one which we are not interested in at this very minute. And if we look at the categories or the sources of preclinical reproducibility, we see biological material and reagents, study design, data analysis and reporting, and laboratory protocols. And this is definitely something where the experts from our field, from the laboratory medicine, really can do a lot simply by teaching, our research colleagues, how to adhere, not saying to the norm ISO 15189. That wouldn't work, but, somehow to extract at least the part of this practice, in a research work. It sounds trivial, but actually it's not. Unless this happens, we will still be in a trouble. The study design, that's another story. Study design really contributes a lot to the irreproducibility of scientific result, and these are one of the reasons. That list cannot be complete. Simply, some material cannot be substituted at all when seeking for human-specific features, and you never get this with any kind of, animal modeling. Cell cultivation alone is selective. We cannot model a tumor microenvironment, and it's nearly impossible to model the immunity response. This is not to say, let me just make a kind of interim summary. For personalized medicine, then, we probably need something which is human-derived. We need rather a person rather than a mouse. This is anonymized, this is obviously a joke. But we have these models here. We have rare diseases, they are biobankable. We have long-term prospective cohorts, they are also biobankable. And we have a long-term survivors in cancer sciences. This is also biobankable, but for some reason it's really not done in a developed world, to have these samples and data available. Why is that when having, two patients treated with the very same protocol, and in one case the patient dies within 3 years, and the one is alive, 12 years after treatment termination. This is not to say from my side that, all the animal models are wrong. Some of them may have heard that, elephant P53 model is a very, very interesting biological model. The thing is that these animals live really long, around 60 years. They don't have cancer, and they have about 20 copies of P53 tumor suppressor gene in their genome. Whether this is translatable to human situation, it remains to be seen. And another very recent case from the reproductive medicine which was very much interesting to me when I was looking for this particular citations. It was an experimental test for the ovulatory homolog model for female orgasm, which was published in PNAS about 3 weeks ago. So again, this model works for rabbits. Whether this model will be translatable to the human situation, it remains to be seen. But from the biological point of view, it was very, very interesting paper to look at. The BBMRI-ERIC access pipeline. What is the access pipeline? Access pipeline is a set of steps, how the researcher, the authorized researcher can approach, things, materials, data, methods, what are in the biorepositories. And out of this busy slide, I will just try to draw your attention to the BBMRI-ERIC Directory and the BBMRI-ERIC Negotiator, which are the web-based tool that are already in place. And at the end of my talk, I try to show you this in vivo directly from the website, because I think, you know, it's in such a stage of implementation that, you know, we can demonstrate it. We can demonstrate it essentially from the stage. BBMRI Directory is, as the title explains, it aggregates the metadata and data about biobanks and about their collections and about the biobank network. This is the web page. We'll look there later. We will look at it later. And this is roughly the map where we can find, you know, the BBMRI-ERIC associated biobank. Roughly, we have roughly around 700 biobanks. 600 biobanks with stated collections, and estimated number of samples in these biobanks is this huge number. I can't even read that, you know how big this number is. The tool, which is a kind of interactive, you know, is the BBMRI-ERIC Negotiator, and I really hope I will be able to show it to you from the screen, because this is actually a tool how you, as a requesters, can send the request, you know, in a parametric format to a specified biobank to ask for what they actually have. Yeah, so that this is the concept of the BBMRI-ERIC Negotiator. The internal architecture is essentially quite simple. You have the structured search criteria. You have a field for the free text specification where you describe. Typically, you put the abstract of your grant application in there, and typically you put there the available ethics approval, because, you know, essentially for every grant application we have to have some kind of local. That's the important element. Local ethics board application. This is, you know, how the negotiator looks from my side or from the side of the IT people. I mean, the noise here is essentially the pseudonymization, you know, that's why, you know, actually my IT people did that in a kind of non-readable way. BBMRI locator is another instrument which is being programmed right now, and the role of this locator, how the system shall look like in the hopefully near future, hopefully a year from now, it should look like this. Here we have our hospital laboratory information and management systems in the specific healthcare institutions. At that institution is operating a tool which is called Connector, which periodically searches for the pre-specified, you know, either samples or data or various features, which then are translated to the BBMRI-ERIC locator. The national directory shall, in principle, correspond to the BBMRI-ERIC directory, but some countries, like UK or the Netherlands, they have some sort of, you know, because they are historically quite further on, so that, you know, they have some kind of their own national directories in place, so that this is a matter of coordination. And then this ends up in the BBMRI-ERIC Negotiator. As I am saying, this is a tool already in place which really enable communication of the researchers from the specified, pre-specified biorepository. As the time goes by, all the biobanks essentially constitute two principal models. One is the population and study-centric biobank. The other are the clinical biobanks. To work within these biobanks is essentially much easier, because they have much more structured data upfront, because they are usually using some kind of predefined models, whereas in a clinical biobanks, it essentially reflects our daily clinical practice. This is the situation why we have essentially the mixture of structured and unstructured data. You need to work with the national language environment, because, you know, in Lithuania I cannot use the same search tool as, for example, in Greece. This is of course. On the other hand, this is a very rich resource of information. This is the richest information available. But I mean, to program all these tools, you know, to make the system working is really a non-trivial element. We did a kind of, this is just to show you a kind of practical demonstration on the CRC cohort, which was processed by the BBMRI-ERIC under the ADOPT InfraDev 3 project. And the reason or the goal of this project was put together throughout Europe, throughout the participating biobank, 10,000 of cases of colorectal cancer regarding just only data sets. These were the data that were actually collected. And all these data were then centrally processed, by the IT headquarters for the continuous data quality checks. And what was surprising, that out of these 600 biobanks, only relatively limited amount of participating biobanks were able to supply to the central registry the data with the requested quality, with all these attributes. So there is a huge room for learning and improving these things before we will be able, for example, to export these data to the Elixir-based repositories, etc., etc. So from this point, this learning was quite important and significant. And some of these are the green dots. These were the biobanks that were also able to deliver some kind of image, some kind of digital pathology, slides, etc., etc. Let's look in brief, to some of the bioinformatics services. The access is here to be to the pseudonymized, not that much to anonymized data, because as I write here, the pseudonymization should be preferred for medical research. Access procedure is something which I try to explain. I try to save a bit of my time to give you the presentation from the webpage. Local expertise in interpreting the data might be needed. This is obvious, and we have clear experience that the request such as give me all you have really does not work. It has to be structured. It has to have some sort of organization within, etc., etc. Utility versus privacy. If we have the data of myself, for example, Dalibor Valik here, and all the hospital-based database with maximum information value, no privacy protection, so this is something what we cannot share. When we are essentially adding noise to this, and we get to 100% noise, we get completely useless data. So that's the reason why we have to move somewhere in this scale, and this is the reason why where GDPR speaks about anonymization, it actually means pseudonymized data, at around the scale somewhere over here, because that's the institution who is responsible for the methods how actually the data were pseudonymized for that particular purpose. Data return principle is one of the interesting concepts, which was put in place by BBMRI-ERIC, simply to say that, what was, let me say, sequenced somewhere shall be returned at no cost to the source biobank, simply to share this information. Yeah, so this concept, I think it's generally well accepted by the scientific biobanking and medical laboratories community. So we will see how this concept actually can come to real life. And there was a very interesting presentation on imaging and laboratory medicine here. So I would just like to add from my knowledge that there is a cooperation between BBMRI-ERIC and the European Society of Radiology to somehow add to this information also the imaging data, so that, not have just a data sample set in the context of written data, in the context of laboratory data as numbers, in the context of pathology data, but also in the context of imaging data such as MRI scans or PET scans. So why this is important? Those of you who were last year on the Euro Biobank Week and who listened to the presentation of Peter Hinson, he very nicely pointed out that essentially 1 out of 20 searches on Google are health related. That's a huge number, and this is something which really pertains, to our daily work, to the work how we prepare sets for research, how we define the future research questions, etc., etc. So that this is something where laboratory medicine really can play, in my view, the key role, because, you know, if I turn the title of my talk from the first slide towards future patient benefit, how to get there through high-quality research with a key role of lab medicine in all its specialties, from microbiology, chemistry, pathology, hematology, cytogenetics, etc., etc., and associated biobanks. Now, if you can please open this link. The link is actually quite simple. Yeah, so that those of you who want to open this on your computers or the cell phones, you're welcome to do it. So once we open that, so we are in the BBMRI-ERIC Directory, and what we can see here are, if I can read this well, 609 biobank. And I would like to ask you if you can open the map of the biobank here. Then we get essentially the pan-European picture of what I was projecting only from the slide. This one is directly from the web page. You can see that the situation here is a bit different. So just stay here, please. Here we have the option for the advanced search, for the rare disease biobanks, user manual, and a couple of things which have to be there, such as privacy statement. Can we go back, please, to the previous page? If we go to the previous page, and if you look to this column, here you have the sorting regarding materials, countries, quality marks. So if we can open countries, please. And if you can open Austria, because I don't want to project, you know, our institution, so that, you know, I have Austria, and I consider Austria to be essentially my country. So So I use this. So here we can see the example of Biobank Graz, which is one of really the biggest. Yeah, some of them may know Professor Kurtz at local, and he is really very instrumental person, you know, in the setting the whole system throughout Europe. And if you look here, so the internal part of the directory specifies the collection. Yeah, so this is the collection, this is the type of the collection, this is the material the collection is made from, and this is a kind of quality standard or the technical specification in this particular case, you know, which this collection follows. And here, this is a number of specimens in that particular collection. If you can go a little bit to the bottom. And because they were able to put all their FFP slides, population-based, they were able to get such a huge number of biological resources, you know, which are accessible here. So that if you send them a request, and that's what we do right now. Can we go up, please? If you just open this. Then we are in the BBMRI-ERIC negotiator. Yeah, so this is just the front page. And what we do now is to click on the login register. We will see what happens. And again, would you be so kind, you know, to roll it down a little bit? Just a little bit. The beauty of this is that for every one of you who have the academic affiliation, you find the institution, your institution in there, and then you can get into the negotiator using your credentials, you know, that you use at your universities. If we can go up again, for those of you who are a little bit more, who are not affiliated with the academic institution, such as company representatives or any other people who would like, you know, to work with and to request the data sample set, then you use this, the life science hostel, where you have to authenticate yourself in a quite thorough way for the negotiation to be started between you as a requester and the biobank, you know, who is at the and who is the potential provider of the material you are requesting. Can we just, escape from that? Back to the presentation. Yes, and if you can put there the last slide, this is the most surprising slide. Thank you very much for your attention. That's what I have to